Hello and welcome to IT Pro Guide. Mohammed Niaz with you. In this video, you are going to watch a demo on how to configure Always On Availability Group for Microsoft SQL database from the scratch in Microsoft Azure environment. So here the advantage is you will see how to set up an Always On Availability Group, and also you're going to see how to set up an infrastructure in Microsoft Azure environment. The topics are prepared in a way to cover what is a database, what are the different editions available in Microsoft SQL database, what is high availability, and what are the different methods for high availability. Up to this, I explain very briefly about all these parts, and I would request you to read more from the Microsoft documentation for any further dive. Then we're going to enter into Always On Availability Group. That is a scope or focus of this video. Then we begin our demo from the scratch. What is basically a database? A database is to store and retrieve data. Now you may be thinking storing and retrieving data can be done in normal file system. Yes, we can do this in the normal file system, but in a database, we can store and manage it in a well-defined data format. An efficient way to handle the data insert, delete, or retrieval or update, whatever it is. From Microsoft, MS SQL is the database product, or that is the name of the database product. There are other products also available like Oracle, MySQL, and many other open source databases are also available for the same purpose. Now let us see what are the available editions in Microsoft SQL. Microsoft SQL have Enterprise, Developer, Standard, Express are the editions available for Microsoft SQL database. So an SQL Enterprise and Developer provide full feature set that fit for critical business applications that need high availability, higher performance, and scalability. The difference between an enterprise edition and a developer edition is the developer edition is free. You can download, but you can use it only for testing purpose, and there is no charge for this. So if you want to practice SQL development, or you want to practice high availability like what I'm going to show you in this video, then you can download developer edition. Then you can begin practicing this high availability or any other feature that you want to explore. An SQL Enterprise is a paid edition. Based upon the number of cores in your server, you have to purchase a license for SQL Enterprise. SQL Standard is also a paid version that is good for mid-tier application, and also you can upgrade from SQL Standard to SQL Enterprise also. Then SQL Express, it is a free one. You can use it for a development, or you can use it for in production even if your requirement is less than 10 GB and you don't need to have a high availability requirement for this SQL database. And if you're interested to know more in detail about all these versions, the comparisons, and the other details, then I prefer you to read the documentation from Microsoft, because if you are going to purchase one of these version for your organization, then you should know what you will get and how you need to license it, right? So I really recommend you to go and read this documentation. Then you will get all the information related to the comparison of these versions. Now let us understand what is high availability. In simple way, we can say a high availability system is a system that designed by considering the loss of service caused by the failure of individual component involved in the design. I will explain in detail. As you can see in the picture, we have three layers here. Web layer is the layer where the clients who access the web application gonna reach. Then application layer, which accept or which collect the request from the user over the web application and gonna update to the database. This is how the enterprise application gonna design. There will be a database layer, application layer, and a web layer. so that this adds more security and more control and more scalable options. So when we say high availability for this entire design, you need to have multiple servers running with the application for web application, for application layer, and for database, and multiple network devices. So if one component participating in this high availability failed, then other server or other device gonna take over and continue the services to the client. So this kind of design is known as high availability. In this video, our focus is only database. So let us see what are the options available for Microsoft SQL in order to use it for a critical application. Following are the high availability options in an MS SQL. We can begin from backup, log shipping, mirroring, clustering failover, always on availability group. So these are the options that you can utilize and set up a Microsoft SQL high availability environment for your application or for your organization. Before I go to this each database high availability feature, let's talk about database and logs. In a database server, when you install Microsoft SQL database and you start writing data into the database, you will have a database file and a logs. So whenever you update a transaction to the database, it first write to the transaction logs, then the completed transaction to the database. So each transaction is recorded in the logs. So it is good that if you lost the connection in the middle of transaction, only completed transactions are gonna transferred into the or written to the database. So you have transaction logs and database file. When the application write the data, it write into the transaction log file. Then the completed transactions are written to the database. So that is it. Now let's go to the first high availability option, that is backup. So backup is not going to be a big topic because you take backup of the database and restore it when there is a failure. So you can back up the database alone, or you can take an image of the entire virtual machine or the physical machine. But the problem here is, if you, for example, if you take only the database backup, and when you want to restore it, you have to set up a new server, then you install SQL, then you restore it. If you take an image of the virtual machine, then restoring the image of from the backup, all this gonna take some time. So your RTO, the recovery time objective, is going to be very high. So if the application doesn't require a lower RTO, it is acceptable for your organization to go with a backup as a solution for your high availability. And if the application goes down, it is okay to wait for another 1 hour or 2 hours in order to get the items back. The next method that we have to discuss is log shipping. In this method, the logs are transferred to a shared local storage, and then it copied to the another database. So your application write into the primary database, then the logs from the primary database gonna be shared to a local storage which the primary and the secondary database have access, and the secondary database somehow get these log files and gonna restore into the database. So by this way, the whatever the application write into the primary database is gonna return back to the secondary database. So we have a primary database and a secondary database in this scenario. The first job that gonna happen in the primary database is backup logs from the database to a shared location. Then the second job is to copy it from the shared location to the secondary database server. Then the secondary database restore these logs into the database. So this way we synchronize the data from primary to the secondary, and all these jobs are automatic. There are some disadvantages. There is a chance for data loss, and there is no automatic failure. You have to manually start up the database if something happened to the primary one. So there is a downtime then, and there is no single connection string. What mean by a single connection string is, for example, if your application is writing to the SQL 1 server, and if there is something happened to the first server, then you manually fail over to the secondary server. That time you have to go to the application and change the connection string, because the connection string was pointing to the first server. So you have to change the server name in the connection string and point to the second one. So there is a downtime in the server, then you have to go to the application and change it. If these are all acceptable, then you can go with the log shipping for high availability option. The next high availability option is mirroring. Instead of primary and secondary database we mentioned in the previous log shipping option, here we call it principal and mirror. So principal database and mirror database. So you don't need to have a shared folder for log transfer. In the log shipping method we had a shared folder, and then there is 3 jobs which complete the data transfer from primary to the secondary database. But here in this mirroring method, you don't need to have a shared folder for logs transfer. It transfers the records directly from the principal database to the mirror database. If the principal database fails, then the mirror server automatically becomes the new principal server if you have a witness server configured. So if you have a witness server configured, you have the ability to achieve automatic failover in mirroring option that you don't have in log shipping option. So, and also in addition to that, you have 2 database copies, as it is named as mirroring. You have a mirror copy of the principal database in the mirror database server, and the configuration is simple, and compared to the other method, the infrastructure cost also low. Then we have always on failover cluster. So the always on failover cluster option is built using the Windows failover cluster. So Windows failover cluster is also used for hypervisor failover also. So with this Windows failover cluster, you can have a always on failover cluster SQL high availability solution. So each server participate in this failover cluster are known as node, and it should be same model, same hardware, same software versions and all. So what you're gonna do here in this always on failover cluster model, prepare a shared storage and connect to the SQL servers. So if you have 3 SQL servers, then connect it to 3 SQL servers, the same shared storage, and the SQL server is going to be online on one node at a given time. And if something happened to the first server, as the storage is already shared to the other servers also, the database is going to be online on the other server, that is other nodes. One important thing that you want to note in this method is the SQL database is going to be stay on a shared storage, and that shared storage is shared with the all the nodes that participating in the failover cluster. So we have only one SQL database copy. We don't have multiple database copy in this method, but in the mirroring and in the log shipping we had multiple database copies. Now coming to the main agenda of our topic, that is always on availability group. So we spent around 14 minutes to speak about other high availability options and the basic idea about SQL database. So always on availability group is a group of database servers, and in that group you have 1 primary server and 8 secondary servers. So this is the total you can go. Primary means you can read and write to the database, but secondary databases you can only do read activities. So just assume you have a single database, and when your application write into the database, it completes the transaction and let the application know that the data has written. So in an always on availability group you have multiple servers, and when your application write a data, it complete the transaction in the primary database and let the application know transaction done. Meanwhile, it transfers the new update from the application that returned to the primary database to secondary database also. So in an asynchronous mode, there are two modes available, asynchronous and synchronous mode. In a synchronous mode, let's begin from the synchronous mode. In a synchronous mode, the primary database server gonna wait till it get the acknowledge from the secondary database also after the replication. So in this case, when the application write the data to the primary database, then it have to write to the secondary database, then it have to wait for the acknowledgement from the secondary database. Then the primary database will notice the application that the transaction has completed. By this way, we assure that there is no data loss. But of course, it adds some latency. But if you have all the servers in the same data center and you have a good backbone connection, then no need to worry about the delay. This can be managed. But if you have one server in one location and the other server in different location, then having a synchronous mode and waiting to complete the acknowledgement from the secondary database is going to be add more latency, and this will affect the performance of application. In async mode, as I told you before, the primary complete the transaction to its own database and acknowledge directly instead of waiting for the acknowledgement from secondary, but at the end it transfer the data to the secondary. So you have two modes, synchronous mode and asynchronous mode. The synchronous mode provide you data protection, but it adds latency. But in an asynchronous mode, it only write to the primary database and take the acknowledgement. It doesn't wait for the secondary to give an acknowledgement. So these are the two modes that you can configure the database in an always on availability group. And once you set up an always on availability group and you have multiple servers, SQL servers in that group, then you can fail over from one server to other server. It can be manual or it can be automatic. Even it can be a forced failover. There is a chance for the data loss in that case. So you have multiple options to switch from one server to other server. And if you look at the nodes, you will see that I have marked it as read and write for the primary, then read only. So we have many nodes with read only. So if the primary fails, as I told you, the secondary become the primary and change the status from read only to read and write. But this read only nodes, the other nodes can be utilized for reporting instead of running the reporting transaction or the backup or read activity to the same primary servers. As you have standby servers which are still capable for the read operations, you can point the read only intended operations like reporting or backup to the secondary database, and this will help you to reduce the load on the primary one. The next thing that we have to understand is AG listener, that is availability group listener. So a client application, if you have a standalone SQL server, the client application gonna connect to the SQL server directly. But when you have multiple SQL server and high availability, then you need to have a virtual IP, right? So that the client application can connect to the virtual IP, and behind that you can align multiple SQL servers, and when one fail, the other node gonna take over, but the client will connect with the same IP address. So that is what the availability group listener, the client application gonna connect to the database, whether it is a primary database or secondary database. All the incoming connections gonna listen by this availability group listener, and by this way the listener provides a fast application failover in case there is a failover of one node that was acting as a primary and the node to take over the primary role. In that case, the AG listener will be diverting the connections. Instead of diverting to the node 1, it divert to the node 2 when it become primary because of a failover. So by this way, the application doesn't need to change the connection string, or you don't need to go and change your DNS IP address. All it will be handled by AG listener. You can also use a witness with the always on availability group. In this case, you can assign a vote to the witness, so that in a 2-node cluster, for example, adding witness will have 3 nodes. Witness will also considered as a node, and you can assign vote for witness. So if node 1 failed, then there is witness plus node 2, so the majority votes the availability, and node 2 will be available, or we can say the cluster service is up and running. And when node 2 failed, in this case also node 1 plus witness is alive, so that node 1 will continue active and the cluster services are up. But when you have a failure of witness plus node 1, then the majority failed and the availability is only on node 2. In this case, you have to manually start up. So the advantage of using a witness, instead of having 3 nodes, if you use a witness, you can save a license if you don't require like 3 SQL servers, but still you require high availability. Then instead of having a SQL server in place, you can save the money in terms of virtual machines and also the operating system and also the separate license for this SQL instance. You can have simply a witness, and this witness can be configured or as a disk witness or a file share witness or cloud witness. In this demo we will use cloud witness. So we're done with the theory part. Now it is time to move to the demo. So I listed all the steps that comes in this demonstration. We are going to begin from the scratch, and as I told you, this SQL Always on availability group we set up in the Microsoft Azure. So you will see how to set up this environment in Microsoft Azure, then how to configure the Always on availability group also. So we're going to begin with the preparation of virtual machine in Microsoft Azure. We need 3 virtual machines, that is, one is for domain controller, then 2 SQL servers. Once the virtual machines are ready, we will set up domain controller in Azure VM. Then we join the 2 SQL servers that prepared to the domain controller running in Azure. Then we install failover cluster for SQL 1 and SQL 2. Then we verify the failover cluster. Then you can add additional disk to Azure virtual machines, and you can rerun the cluster validation if you met any error while verifying the cluster. After you prepare the cluster well, then it is time to install SQL Server. Once you complete the SQL Server installation, then create a cluster, then add witness. In this demo, we use cloud witness because that is easy. I don't want to create another virtual machine for witness purpose. But in an on-premises environment, if you have like unlimited virtual machines and you prefer to have an additional server for a witness, or you can use a domain controller also for the witness purpose. Then we create availability group. So we add the SQL 1 and SQL 2 once we create the availability group. Then we have to enable firewall, cluster services, then TCP IP. If you didn't enable this, you will find some errors while adding this availability group. So these are some of the points that you also spend time to troubleshoot and find why this availability group is not working. So we'll go through that part also. Then we create a listener. So I explained to you a listener is how the application is going to be connected, and we align all the SQL servers behind the listener so that we get high availability, and this make the failover process fast. But when you create a listener in an Azure environment, it is not going to work straight away. You need to use internal load balancer in order to work the listener. But in an on-premises environment, it works out of the box. You don't need to do anything. So that is it. Then finally we will see how to fail over from one database to other. So let's begin our demo. So the first step is to create a virtual machine for domain controller. So I have logged into Microsoft Azure. Then I'm going to create a new resource group. Let's name it SQL cluster. Then select your subscription. Then give a name for the virtual machine. Then select the region. Then select the size. At the end, enter your credentials for the new virtual machine. Then RDP is enabled by default. So this is how we are going to connect. Then click on review, then create button. If you want to have a look at the disk networking and other things, you can go through it. But for me, I usually go with the defaults if there is no other configuration is required. Now click on the create once the validation has completed. Now the domain controller is getting ready. Let's go back to the home and create other virtual machine. So the domain controller is ready. The next is we need 2 SQL servers, right? So let us create 2 virtual machines for SQL. I'm going to name it SQL1. Then I select the same group, resource group that we selected or created when we prepared the domain controller. Then give username and password. Then click on review and create option. Once it complete the validation, click create and that will deploy the SQL server 1. Now we're done with the domain controller and SQL server 1. Let's create one more SQL server so that we will have 2 SQL servers. Select the same subscription, then select the same resource group, then give a name for the virtual machine, then enter the credentials. So what you are entering here is going to be the local admin credentials. Click on the review and complete the validation, click create. So now we done with the virtual machine deployment. We have 3 virtual machines ready for always on availability group. Next we are going to connect to the domain controller virtual machine. Then we need to prepare this virtual machine as a domain controller. So in order to connect, you can use connect RDP option that will help you to download an RDP client, and from there you can remote desktop to the Azure VM and enter the same credentials that you gave when enter the same credential that you gave when you prepare the virtual machine. Now let us add the domain controller role. For that, from the add role wizard, click next and select the server, then select the server role, that is Active Directory domain services, then complete the wizard. Now let us promote this virtual machine as a domain controller. So this is going to be the new forest, that is pkiblog.com is my domain name. Then click next, enter the directory restore password, then complete the wizard. So now the domain controller is ready. The next step is to join the other virtual machines, that is SQL1 and SQL2, to the domain controller so that it will be a part of the domain. So in order to join this SQL1 and SQL2 to the domain controller that we prepared, go to the network configuration of the virtual machine, then from the DNS server, select custom, then enter the DNS server IP address, that is 10.1.0.4. So this is the IP address of the domain controller that we just prepared, and this is where you have to enter the DNS IP address. You are not allowed to edit the network card and adding the DNS. This is not going to work. If you want to join your virtual machines to the domain controller, this is where you have to come and configure the DNS IP address. You can repeat this step for other virtual machine, that is SQL2 also, so that we will be ready to join to the domain controller. So now the SQL1 and SQL2 has configured for the DNS. Now let us connect and join this SQL1 and SQL2 to the domain controller. So as you saw that I click on the start button because those machines were off. Once it is start, then you can click on the connect button. Thereby you will get the RDP, remote desktop to the virtual machines. So I started, then after a while I'm going to connect over the RDP, that is remote desktop. Enter the credentials that you give. Now these credentials are the one I gave when I prepared this virtual machine from the Azure wizard. Later, once I join to the domain controller, I can use the enterprise domain administrator credentials to log into these virtual machines. So let's click on the work group. Then from there you can click on the domain, then enter the domain name, that is pkiblog.com, then click OK. Then it prompt for the administrator credentials. Simply enter the admin credential informations, then click OK. As you can see, now it has joined to the domain controller. Repeat the same step for the other SQL server also. The next step is to install this Windows failover cluster role in SQL servers. For that, log into the SQL server, then click on add roles and features, then click next. From the features you will find failover clustering. Click on the failover clustering, then complete the wizard. Now the failover cluster installation has completed. You need to have a restart on this machine. You have to repeat the same step in SQL 2 also, and you can go to this add roles and features wizard and repeat the same step. Once you complete the failover cluster installation and restarted your machine, then you can right click on the server, then find failover cluster manager. So you don't have any cluster created at this moment. What we're going to do is we are going to validate the configuration. For that, click on the validate configuration, then click next. Now enter the SQL Server 1 and SQL Server 2, then click next. Now you have an option to choose the test selection, but I give all. Now it is running the validation, so you will get a report, a very good report, and based upon that you can see that the environment is ready to go for this always on availability group, or you have something to do. So let's wait for the summary. So now if you click on the view report, you will see what are the errors, what are the warnings, and some of them are marked as success. So this you can evaluate and take further decisions. So you can see we have a network, and also we have some storage related configuration. It's saying that you have only one pair network. That is fine, because this is for a test purpose. Then what else we have is system configuration, then validate the software update level. So you can keep the system updated. I ignore this because this is also for a test system, so it's fine to continue like this. And you can see validate storage spaces, that is no disk were found. So if you want to add additional disk, I'm going to use the default location in this demo, but if you want to add additional disk, that is what we are going to see, how to add additional disk in Azure. To add additional disk to the virtual machines running in Microsoft Azure, go to the virtual machine. From the settings you will see disk, and from there you have an option create and attach a new disk. So enter the disk name, then storage type and size, then you can create and attach a new disk. You can see you have a different option based upon the type of hard disk you selected. The IOPS will change. So if you don't need a premium SSD, then you can go for standard, or based upon the performance that you need, you can choose one of it. So what I did, I have two SQL disk, one for SQL data and one for SQL log with a size of 20 GB and 10 GB. Then click on the save. That will add this disk to the virtual machine. I have repeated the same step for SQL 2 server also. So we have two new disks, one for the data and one for the logs. As I told you, I will be using the default location, but I just want to show you, like in case if you want additional disk in Microsoft Azure, how you can add it and how you can make it available in the server. because in best practice or in production environment, anyway you have to create a separate disk for logs and for database. So now you can see that the disk 2 and 3 is pop up here, and you need to initialize it, and you need to format to a file system that you required for your operating system. So here you can create a new simple volume on top of the disk that we added. So the one we are now doing is the 20 GB. So if you want to give a volume label name, for example SQL data, and for logs SQL logs. So you can repeat the same step in the SQL2 also. What I'm here showing only for one server, but if you want to repeat this to the other server, I'm explicitly saying that you need to repeat it. So if you are trying this with me in Microsoft Azure or in your environment or in your organization, then you have to make sure that you did these actions on the other server also. So now the disk is ready. If you go to the my computer, you can see we have an SQL data and an SQL log file. As we have added new disk to the SQL cluster, let's go back to the cluster manager and rerun the cluster validation. So click on the failover cluster manager from the SQL server. We don't have any cluster yet, so just click on validate configuration. Then as we did before, enter the server name, then click next, then select all the tests. And now if you look at the results, you can see that the disk, there is no warning from the disk side. So this is how you can go through the results from the validation and correct it and come back and rerun it again and make sure that you have followed all the best practices that is required for a Windows failover cluster. So next we are going to install the SQL Server application. For that we need to download SQL Server Developer Edition. Then we install the Developer Edition. After that we also install SQL Studio Management Tool on SQL servers. If you want, you can install this Studio Management Tool on domain controller, SQL servers and all. SQL Studio Management, the main intention of installation is to manage the SQL database servers. So we have to install this Developer Edition in SQL1 and SQL2. Then the Studio Management, based upon the machine that you manage this SQL database, you can install it. I'm going to install it in SQL1, SQL2 and domain controller also. So from any server I can manage these databases. So I have connected to one of my SQL server. To download a Developer Edition, you can visit Microsoft SQL database website. Then from there you will see a Developer Edition option. As I told you, it is a free edition, but only for development and test purpose in a non-production environment. But you are also open to use SQL Express in case if you want a free database in production. So you can complete the download and installation. It is a straightforward installation. There is nothing to do. So now the installation has completed. Now you can see that we have installed SSMS, that is Studio Management for SQL Server. So you can click there and you can download SQL Server Studio Management from here. So we're gonna manage the SQL Server using the Management Studio. So now let us install Studio Management tool. That is also a straightforward installation. There is nothing to do in between. Once you complete the installation, restart the server and repeat the same step in the second SQL server also. You have to download the Developer Edition, install it, and if you want SQL Studio Management, then do the same in the second server also. Once you complete the installation of SQL Server Management Studio, then you can start managing your SQL server from the new tool that we installed, SQL Server Management Studio. To authenticate and connect to my database, I'm going to use Windows authentication. So I have connected to the database. I don't have any database at this moment added from my side. Those are the default databases what you see there. So we have completed the installation of SQL Server application. The next step is to create a Windows failover cluster, and we have two SQL servers only. So when you create a cluster, in this case you need to add a witness also. So the different options to add a witness, in this we're going to use cloud witness. So I have opened failover cluster manager. From there, click on the create cluster option, then click next, then enter the servers that you want to add to the new cluster. So we have two servers, that is SQL1, then SQL2. Then click next. Now you can give a name to the cluster, then click next. Now you confirm. Now you can review the information and confirm it. So now a new cluster is creating, and once it complete, you can close the wizard and the cluster will be ready for you. Now you can click finish and close this create cluster wizard. As you can see, now we have a new cluster popped up in this window, and if you expand it, you will see nodes where you can see two SQL servers that we added, then cluster network. So once you created the cluster and added the servers as a part of the cluster, then the first thing you have to do is go to the SQL Server Configuration Manager, and from there right click on the SQL Server. Then you can see always on availability group. You have to enable always on availability group, and for this to be take effective, you need to restart this. So simply right click and restart it. So I just performed it in one of my SQL server, and I have to do it in the other server also. So make sure that you executed this in both servers also. Now we need to configure witness. For that, you can see more action option, then configure cluster quorum settings, then click next. So you have different option. You can use a default quorum configuration, or you can choose a quorum witness. So our option is select the quorum witness, and I'm going to configure a cloud witness. So now I have to give the Azure storage account, then Azure storage account key. So let's do that. What you see now is the Microsoft documentation for deploying a cloud witness. So I have logged in back to the Microsoft Azure portal, and I have to create a new storage account. Then I need to copy the information from Azure portal and give it to the SQL Cloud Witness wizard. So let's create a new storage account, give a meaningful name for the storage account, and you can select local redundancy option. Then click on review, and once it complete the validation, you can simply click create, and that will deploy the new storage account that we created. So the deployment is in progress, and in short, we will have the storage account ready in Azure. Then we can copy the storage account name and key and give it to the Cloud Witness wizard, and that will complete the witness part. So now let us copy the storage account details. You can click on the show key option, that will display you the keys. Then from there you can copy the storage account name and storage account key, then enter it in this wizard, then complete the wizard. So you have a cloud witness and two SQL server in Azure. So in total we have 3 nodes. You can see that the cloud witness is shown in the failover cluster configuration. So I have created a new database now, and if you refresh and expand the database, you will see my new database, that is user registration 2. So we have a blank database ready, and inside that I have one table, that is persons, DBO persons. So we have a new database and a new table without any data. Now the next step is to create a always on high availability group. So you can see always on high availability option, and from there is a availability group. So just simply right click from the availability groups, and that will show you new availability group wizard. Then click next. So you can specify a name here for availability group, and you can also select is it external, none, or Windows Server Failover cluster. So here our choice is Windows Failover cluster. We already configured Windows Failover cluster, and we also enabled it in the SQL configuration manager for this always on high availability group, for this always on high availability. So let's give a name for this availability group. So SQL AG1 is the availability group name that I have given. So one of the requirement of this availability group creation wizard is you need to have a full backup of this database. As you know that I have just created this backup, so I don't have a full backup of this database. So I need to do that first before I complete this wizard. So you can right click the database, then from there you will see tasks, and there you can complete a backup of this database into one of the local disk of your server or somewhere else. If you already have a backup for this setup, then no need to do this. You can do this from the backup application. But if you're trying this like what I'm doing now, then you can simply back up to the same one. So I'm going to rerun this AG creation wizard. So AGSQL 1, then select Windows Failover cluster. Now you can see that we already met the prerequisites, that is a backup. So here you have to add the SQL2, as we are running this from the SQL1. The server instance SQL1 has already added to this. So what you have to do is you simply need to authenticate and complete the connection to SQL2, and that will add your SQL server to this availability group. So here I face some connection issue, and you can sort this out by checking the firewall. You can create a new firewall rule and make sure you have added the SQL server port to connect between SQL1 and SQL2. Once you open the firewall and you find an issue again for connecting from one SQL server to other, then you have to come the SQL Server Configuration Manager, then enable the TCP IP option in the protocols for SQL Server. So you can see I have just enabled it. Now I will be able to connect from SQL Server 1 to SQL Server 2 over network and vice versa. So you have to repeat this step in both SQL Server if you find this disabled in your SQL Server Configuration Manager. So once you open the required firewall port and also this TCP IP enable, then you can simply restart the SQL Server from SQL Server Configuration Manager, and now you can make a test using telnet command. So simply telnet from one SQL server to other one and use the port number 1433. So now you can see that the port has opened. Before when I tried it was closed. So either it is a service issue or a port issue. We have succeeded in connection, but still there is always on feature is not enabled. So I forgot to enable the always on feature in SQL Server 2. So what I'm going to do is again I go to the SQL Configuration Manager of SQL Server 2. Then I simply need to click here. This will enable the always on availability group with this Windows Failover cluster. So and just restart the SQL Server service, and that will help me to complete the availability group wizard. So let's go back to the availability group wizard, then click connect. Now you can see that we fixed the issue with the firewall, with the service, and also with the availability group enable in SQL service. So we have SQL1 and SQL2 added. Now it's time to click next and complete this availability group creation. So we have availability mode option, that is a synchronous commit. You have two options, either synchronous or asynchronous. If this is in the same data center and you need a data protection, then you can use synchronous commit. Otherwise, you can use asynchronous commit based upon your requirement. Then you can see that if you use synchronous commit, the automatic failover is only up to 5, but if you use asynchronous, then you have an option up to 9. So those choices are completely based upon the requirement. And the difference between the primary and secondary, the data will go and write the difference between the primary and secondary we already explained. Primary will have the read and write capability, and the secondary will only have read capability. Once it fail over from SQL Server 1 to SQL Server 2, then the SQL Server 2 will become the primary. That time the SQL Server 2 will have the read and write capability. Then you have an option that the secondary you can make it as only readable, so that it will be useful when you have like a backup or a report servers. You can avoid the load on the production on the main server, that is the primary server, and you can leave the secondary for purpose of reporting or backup, like that. So you have an option to connect the read intended application or the read intended activities to secondary, and write intended activity to primary in availability group. Then select your synchronization preference, then click next, and you can see all went well except the listener configuration, but that is fine. Let us complete this wizard, and we can create the listener after we complete the availability group creation. Now click on the finish, and that will complete the configuration of availability group. So now we have a new availability group with two SQL servers running, and one primary and the other one is secondary. What is pending from our side now is the listener creation. We have to create a listener so that we will have a single IP for our application to connect, and this single IP will connect to the primary server, and when there is a failover, the single IP address is still what the application need to use, and behind the scene the primary will change to secondary, or the secondary will change to primary based upon the availability of the servers. But for the client application, they only need to connect to one connection string. Now we are going to create a listener that you can do it from the SQL Management Studio, where you can see availability group, the new one we added. Simply right click and add a listener. What you have to do is simply give a name for this listener, then the port number, that is 1433, then choose a subnet. So once you choose a subnet, you can give a static IP address here. Then this will be added to the DNS automatically. So from here onwards, you can give the applications to use this IP address, that is SQL AG is the DNS name of the listener, right? So that the application can use this DNS name, that is AG listener DNS name, to connect to the database. From the DNS, you can see there is a new entry, that is SQL AG for the listener. So after all these, when I test the failover between SQL Server 1 and SQL Server 2, the failover I able to complete successfully, but the listener IP is not reachable after the failover. So let's try what is happening here. I'm going to failover from SQL 2 to SQL 1. At this moment, SQL 2 is the primary. So simply finish the wizard. The failover is easy. You can see I just start failover wizard, then select the SQL server and completed it successfully. Now after the failover, I'm not able to connect to SQL AG. you will see if you try to ping to the SQL AG, you will see that the ping failure. So the reason is I'm running this in Azure environment. So when you create a always on availability group in an Azure environment and you failover from SQL1 to SQL2, then you will not be able to reach to the SQL2 from SQL1 with the availability group IP address. The reason is the broadcasts are blocked within Azure Virtual Networks, and therefore this method is not going to be supported in an Azure environment. So you can handle this with internal load balancer. So let us create an internal load balancer to fix this issue. So for that, from the Azure, go and create a new internal load balancer. Select the subscription, then select the resource group, give a name, then select the type internal, then select the virtual network where the SQL server is connected, then IP assignment, static, then the IP is the same IP address of my listener, then click create. Then once the validation completed, again click create. So now you have created a load balancer, internal load balancer. So now we need to point out both the SQL servers to this internal load balancer. So any traffic come to the AG listener IP address, internal load balancer will handle the traffic to the AG listener. So we are going to add the backend pool here, and you have options. Either you can select the network address or you can put the IP address. So we have two servers, that is one is 10.1.0.5, then 10.1.0.6. So let us add these two IP address. These are the two IP address that need to be balanced using this internal load balancer. So we have the front-end IP configuration and back-end IP configuration. Now we need to create a load balancing rule. Give a meaningful name for the load balancing rule. Then select the load balancer front-end IP address, then backend pool, then the port address, that is 1433 for the SQL. Then you have health probe that you need to configure here. So if you don't have any health probe created, you can create it here. So select the protocol, that is TCP protocol, then the port number for health probe. So the probe port number that you have configured here need to be configured in the SQL server also. So now we done with the configurations. So now we added all the necessary load balancing rules required. So now we completed with the load balancing rules. So next we are going to set up the probe port that we configured in the internal load balancer. So if you run this command, you will see the probe configuration, that is get cluster. You can see that the probe port is 0 here for AGSQL1. So what we have to do is we have to add the port number that we give in the internal load balancer. So now through a PowerShell command, we need to configure the health probe of Windows failover cluster, the same one that we configured in our internal load balancer. So run the following command in your environment, and that will configure the listener probe port as 59999 as I configured in the internal load balancer. As we configured the listener probe port, now we need to take the cluster down, then run it again. So this will enable the configuration on this cluster. So let's start it now. And now you can see that the listener is pinging, so it's fine. Now we can test the failover, and the connection will continue with the application because we have an internal load balancer and the failure, and we configured the health probe also. Now we are going to test the failover. So you can right click on the availability group, then you have an option on the right top, start failover wizard, then simply click next. Then now the SQL1 is secondary, and we're gonna make SQL1 as primary after the failover. Then click finish to complete the failover. You can copy this script and keep it somewhere, so whenever you want to do it, you can even do from the commands instead of going through this wizard. Now we switch it from SQL2 to SQL1. So let us summarize what we have learned in this video. We saw from the beginning how to set up virtual machines, networking, domain controller, how to add DNS IP address to the virtual machines, how to join to the domain controller. So very basic things in Azure infrastructure. Then we started configuring Windows failover cluster, then SQL installation, SQL availability group, then internal load balancer, and finally we tested the availability of SQL server. So that is all. Thank you for watching this video. For more videos, subscribe this YouTube channel.